In this video, we're going to go over using the chat system with LiveAmp to tune a vehicle for hands-free phone calling. So coming over to LiveAmp here, you can see I have already connected LiveAmp to the target. I've paired the chat's Bluetooth control unit to the infotainment system in the car, and we have simulated a phone call. So the voice library is active and we have level meters, audio is flowing. I've set up my automation tab with all of the details that we need for testing, and all of my tests are available and ready to go. If you need help getting your system to this point, I recommend going back and watching the video where we go over setting up the chats for bench testing with vehicle pre-check, because it explains kind of all the stuff in there. And also, because we already did that video, we're going to just skip over the pre-check portion of tuning. In a typical scenario, when you put the chats in the car for the first time, you'd want to run all of the pre-check tests again, just to see how the microphone and loudspeakers are performing and the audio system in general. But to cut down on time, we're gonna skip those for now, and we'll just do the automated tuning portion. So the first test we want to run always, whether we're doing pre-check or tuning, is the prepare target test. So we just run that now. And that just pushes over a binary config that flattens out the system, gets the system ready to test. If we want to check to make sure that really did what it's supposed to do, we flip over to the voice tab, and you can see that the controls are not enabled right now. There's no parameters set. EQ is enabled but has no node set currently, and the same thing is on the send side. We have switches that are on or idle and ready to be tuned, but all the parameters are just at their defaults for now. So going back to the automation tab, the first test we want to run is the set ref delay test. So the most important thing by far in hands-free tuning, by far, is to get the hands-free reference delay correct. So this is the delay between audio going out of the voice library, out the loudspeakers in the car, coming back in the DUT microphone, and arriving back to the voice library. That latency value, it needs to be right on. It needs to be not changing, and we need to really have that nailed down before moving forward. If we don't get that right, echo cancellation will just not work. So this is really important. The way we used to do it in the past, and we still do it, is to go to the voice tab here and go to the mic config tab, and there's start microphone click test. Now that button is going to start a click test in the car that will automatically measure the latency. This test is baked right into the voice library, so you don't need chats to run it. You don't even need LiveAmp to run it. You can run it from the command line. But because we're going over automation with chats in this video, we're going to go to this automated test to do the latency. And I'll run it. It's just going to play a noise burst to the head unit to play out the loudspeakers, and it will get recorded on the DUT microphone, and a latency calculation will be displayed. So I have a microphone in the car so you can hear everything that's going on in the car as well. And you can see it's telling us latency is 29.7 milliseconds. Suggested value is going to be 30. So that's great. Before I go ahead and set this parameter, I'm just going to run the test a few more times. Okay, suggested value 30, and just one more time. Okay, so you see these values have not changed at all. They're rock solid. That's exactly what we want to see in our system. If in your system the latency value is changing significantly, more than a millisecond or two, that can be a big problem. A changing latency value is really, really difficult for the echo canceller to deal with. And if the value changes more than a few milliseconds, then echo cancellation will fail. So that's the most important thing to figure out with your hands-free system. When you go to tune it, this value really needs to be rock solid. If you do happen to see a slightly changing suggested value through all of your tests, and you should run this test multiple times over multiple calls, if you do see it change a little bit, the recommendation is to take the lowest number that you ever see. So if I did this test 4 times, 3 of those times it's 30, the 4th time 29, I would set 29. But for now, 30 is a good number. I click set parameters. That's going to take that value and push it over to the target in real time. So now the target in the car has this new value. Okay, and I'm just going to click this little pin beside the test to add it to our report. So I'll talk a little bit more about the report later, but for now, all the tests that we want to add, we're going to add. So the next test, set receive AGC. So this is a Bluetooth test. It's going to go through the Chats BCU and use a speech file to set the voice library receive AGC. I've cut down the length of all of the speech and audio files that we're going to be using just to save time in the video. When you run this, your files will be quite a bit longer. So just a heads up.
The last switch cannot be turned off.
It's easy to tell the depth of a well.
4 hours of steady work faced us.
Okay, so here we have some suggested values for receive AGC. I'm going to go ahead and set parameters. That's successful. They're now set to the target, and I'm going to add this to our report. And I'm just going to jump over to the voice tab, and on the receive tab, confirm that my parameters have stuck. And here you can see those suggested values for min, start, and max have been added automatically, and they're good to go. So we can move on. Bluetooth set receive fixed gain nominal. Okay, so this is going to set the nominal volume for playback in the car. And what it wants us to do is set the amplifier volume right at its midway point, and then it's going to recommend a receive gain value to make the playback in the car equal about 66 dBA at the Chats mic, which is in the driver's seat.
Oak is strong and also gives shade.
The goose was brought straight from the old market.
The boy was there when the sun rose.
9 rows of soldiers stood in line.
So I had already preset the amplifier volume to be right at its midway point there. I know in my system that's at 25. So we are a little bit under what we wanted to see, which is a 66 dBA. So it's going to suggest that we set a receive gain for nominal playback 2.35 dB. So we set that parameter, add this to our report. And then on this test, we'll just run this test again because you can see we have applied this receive gain. So now it should actually pass. It should be playing back at 66 dBA. So we'll just run that one more time to verify.
Oak is strong and also gives shade.
The goose was brought straight from the old market.
The boy was there when the sun rose.
9 rows of soldiers stood in line.
Okay, so our LEQ comes back at 66.6 dBA, and that is within 1 dB of our target, so we get a pass for nominal gain at this point. That threshold and the target and the threshold can be adjusted in the test definition. You just open up the XML file, and it's really obvious in there where it is. Okay, so we have nominal playback volume. Let's go on to setting the EQ.
The last switch cannot be turned off.
It's easy to tell the depth of a well.
Okay, so if we look down at the graph here first, the red line is the frequency response of the loudspeakers at the playback path in the car. And you can see there's a couple places where it goes outside of the mask tolerances. Down here at about 500 hertz, and then way down at about 100 hertz, it's up pretty high. So the green line is what the suggested nodes should do to that playback response after we apply them and rerun the test. So let's set those parameters. Okay. Let's add this to our report, and then let's move on to the next test where we verify that that EQ is now within the tolerance.
The last switch cannot be turned off.
It's easy to tell the depth of a well.
Okay, and there you go. It all fits perfectly within, and it's looking good. And you could probably actually hear that on the recording too, the difference that that EQ made in the speaker playback. It's just a bit flatter, cuts down on the extreme low in the bottom, and then that big dip at 500. So that is looking great. We will move forward. Set receive DLC. Oh, sorry, let's pin this to our report as well. Okay, for the DLC test, we just want to be super quiet. It's going to take a measurement of the noise floor in the car and then calculate some parameter values based on that. Okay, so we set our parameters. Great, and pin that to the report. The DLC, the dynamic level control parameters, that's a good one to do a subjective verification of if you can take the car after the tuning for a ride and make a phone call, hands-free phone call to somebody, and then have them just speak normally while you increase the noise in the car somehow. So either driving faster or turning the fan on high, doing something to increase the noise, and seeing how the level of their voice goes up or down in relationship to the noise level in the car. Now, this test just sets this based off the quietest possible condition of the car. So it's just a good thing to go and verify in the real world if you have that ability. RLO, we're going to skip for now. That's a receive loudness optimizer. And that just basically uses a multiband limiter to cut down on a distorted system if you have a distorted system. I happen to know this one is not too bad. And just to keep things a little bit faster for the video, we won't run that test. So Bluetooth, set receive fixed gain max. Okay, so this is going to be setting our loudest possible playback in the car. So I'm just going to go over and reach into the car and turn the amplifier up to its maximum possible setting, and then we'll run the test after that. All right, so amplifier is at maximum, and we run the test.
Oak is strong and also gives shade.
The goose was brought straight from the old market.
The boy was there when the sun rose.
9 rows of soldiers stood in line.
Okay, so we are 85.9 dB, and our target is 84. So we are over by a little bit, and it is going to recommend that we set this gain value. Oh, because I guess we did have a current receive gain in there already, so it's dropping it down by 1.5 dB. So we set this parameter, and we just run the test again and see if we are within the right range now.
Oak is strong and also gives shade.
The goose was brought straight from the old market.
The boy was there when the sun rose.
9 rows of soldiers stood in line.
Great, so now we have a pass. So let's add this one, the passing one, to our report and carry on. Actually, before we carry on, I'm just going to set that volume back down to nominal, just in case we forget to later, and I don't want to keep it at maximum volumes. Could hurt someone's ears. All right, so I set it back down to the nominal point, which on my system is 25. The maximum volume is 50. So let's move on to send side. Okay, so set send AGC. This one plays a speech file through the chat's mouth into the DUT microphone, and will calculate some AGC values on the send side for us.
The last switch cannot be turned off.
It's easy to tell the depth of a well.
Okay, so we have suggested send AGC gain values, set those parameters. Good. Pin this to a report. Yeah, we can go over and check to make sure that they got set in, and they did, which is great. Oh yeah, there's our EQ on the receive side that we had set before. Everything is looking good. So set send EQ. So this is much like the receive side. It's going to create an EQ on the send side for us. So again, we're playing speech through the chat's mouth, going into the DUT microphone. And if we need to add EQ, it will generate that for us.
The last switch cannot be turned off.
It's easy to tell the depth of a well.
Okay, so if we look at this graph, the red line is the current frequency response or magnitude response of the DUT mic in the car. And that, to me, looks like a very typical hands-free microphone that you might see in a vehicle, where it's got a little bit of a boost here in the mid-highs, and it's got a pretty significant cut down in the lows below 500, 600 hertz. So the green line is going to be the predicted outcome after we apply this EQ. So let's do that. We set these parameters, we pin this, and the next test is the verify. So we will verify.
The last switch cannot be turned off.
It's easy to tell the depth of a well.
Great, and we have a passing result after setting that one. That one you wouldn't actually hear the difference in the car because the stimulus file remains the same. The EQ happens to the microphone signal. So that's for the benefit of the person on the far side of the call. If you had somebody on the far side of a call, they would hear that EQ change the signal. Okay, Bluetooth, set send fixed gain. So we're going to set our send loudness with this one.
4 hours of steady work faced us.
We frown when events take a bad turn.
Rice is often served in round bowls.
The hogs were fed chopped corn and garbage.
Okay, so capture file loudness is not within 1 dB of target. So it is telling us that we are much too hot in the sending direction. So we should actually add minus 10 dB of send gain. So let's set those parameters. And with this one, this is another one where we've set the parameters. Now we run it again to verify that the new values allow us to pass.
4 hours of steady work faced us.
We frown when events take a bad turn.
Rice is often served in round bowls.
The hogs were fed chopped corn and garbage.
Okay, and we are still failing, so I wonder if I actually did set that parameter or whether it didn't take. Oh, yeah, okay, so we're at minus 10, and it says that we are not within 1 dB. Oh, we're very, very close to being within 1 dB, so it has a new suggested value. We set that one, and we try one more time.
4 hours of steady work faced us.
We frown when events take a bad turn.
Rice is often served in round bowls.
The hogs were fed chopped corn and garbage.
And we are still failing. It may have been because I heard the fan system come on in this room during the first test. So it's telling us to go back to minus 10 dB. And the fan is off now, so let's try that. That might actually work.
4 hours of steady work faced us.
We frown when events take a bad turn.
Rice is often served in round bowls.
The hogs were fed chopped corn and garbage.
Great. Okay, with no fan on, then the original suggested value was a good one. So we set that, we pin that to a report, and that's a good idea to do. Noise conditions change in the room, and those the tests are sensitive to them. So it's a good idea with all of these tests. We're going through really quickly here, but it's a good idea to run all of the tests a few different times, just to see and make sure that the results are the same. But we'd like to see that pass, so that's great. And let's move on to setting the REC. This is the amount of residual echo cancellation.
Oak is strong and also gives shade.
The goose was brought straight from the old market.
The boy was there when the sun rose.
9 rows of soldiers stood in line.
Cats and dogs each hate the other.
The sink is the thing in which we pile dishes.
A rod is used to catch pink salmon.
The beach is dry and shallow at low tide.
The pipe began to rust while new.
A whiff of it will cure the most stubborn cold.
The source of the huge river is the clear spring.
The idea is to sew both edges straight.
Open the crate but don't break the glass.
The facts don't always show who is right.
Kick the ball straight and follow through.
Okay, so pass, detected echo is less than target. That is great. It shows our percentage of frames with echo detected at 1.6%, and our target is 6%. So these are just these values can also be changed in the test definition to 6%. Target passing percentage can be updated to whatever you think is a reasonable value. But that's great. So we set that parameter and we attach that to our report. And then that is pretty much all of the major parameters to tune for hands-free. So if we want to take a look at the report summary, just go Show Report Summary. It will autofill in a date for us. We can put in a location if we want. If you want to add more rows, you can do that and put in some other details. But we don't have to go through that right now. It gives us a summary of all the tests that we've run and suggested parameter settings. And then it lets us actually write the final QCF or tuning file. So if you want to take a look at the QCF and the parameters that are in there, you can open it in comparison. Oh, right. Okay, so more than one instance of receive gain found. So when you're making a binary config, you can only have one instance of every parameter. Otherwise, you wouldn't know which instance to use when setting your target. So because we did two tests that set the quad receive gain, we have to get rid of one. And the one we wanted to get rid of was from the nominal test because we wanted to keep the receive fixed gain value from the max gain. The gain that we set in to achieve our maximum receive fixed gain is the one that is the most important to us because we always want the user to be able to achieve that highest amount of gain. So this suggested value is 55. We want to keep that one. We want to go back to our nominal gain value, and we want to just click on this P plus to remove that parameter from the report summary. If you click on it, you can see it comes back in. You can either remove it here or remove it from there. But okay, so now that parameter is removed, we should be able to view our binary config. We click to view it in the comparison tool, and you'll see it has our initial switches that we had set on for tuning, plus all of the parameter tuning tests that we've run. And this is the makeup of the final tuning config, basically. So we can just push it to the target and restart, so that our target now has that final tuning config pushed to it. Every time it's restarted, it will load that tuning config. And then we probably want to save it to the hard drive just to be safe. So we save that somewhere to the hard drive, and we are pretty much done our hands-free tuning.